Welcome to this tutorial on the basic use of inertial navigation in the Mirage F1. We will go over the use of the PCN navigation control panel used to control the inertial navigation system, the IDN navigation indicator and how it links with the inertial navigation system, editing and selecting inertial navigation waypoints, and the concept of INS drift and INS fixing. Hello fellow virtual aviators, we are back in the gynotico-lobomasophilic Mirage F1, and today we'll be looking at the principles of inertial navigation and how we can use our onboard systems to help us find locations and travel from A to B. Now the inertial navigation system, or UNI, Unité de Navigation Inertielle, is not present in either the Mirage F1 CE or BE. So we will be wholly concentrating on the EE variant today. In INS navigation, locations are represented by waypoints, geographical locations the parameters of which have been programmed into the aircraft's computer, and to which the INS, or Inertial Navigation System, can direct us to. We have already briefly looked at the INS in our tutorial on startup procedures in the F1 EE. Essentially, it is a system that can measure changes in an aircraft's position, as well as changes in an aircraft's velocity and orientation, without the need for an external reference, such as a beacon. It does this using a series of sensitive but not perfect gyroscopes and accelerometers, which provide inputs to a computer, and then through the magic of integral calculus, it then calculates how the aircraft has moved. Because it can tell how the aircraft has moved and is moving, it can tell where the aircraft is, measured from a starting known reference point, which is obviously essential for navigation. For our tutorial today, we will assume that you have already aligned the INS using the procedures shown previously. To demonstrate the use of the INS, we will fly a simple patrol mission here in Egypt. We will take off from El Gora Air Base, which is the home of the multinational force and observers, and we will fly south over the wilderness to the magnificent St. Catherine's Monastery at the foot of Mount Sinai, before proceeding to the resort of Sharm el-Sheikh. We will then turn north-northwest and head towards Kibrit Air Base, near the south entrance of the Suez Canal. We will then locate the Great Pyramids of Giza, over which we will execute a navigation fix before returning to El Gora. Waypoints have been programmed for these, ostensibly by the crew chief, but in reality in the mission editor. This information will be automatically loaded into the Mirage's INS system upon spawning. First, let us look at the PCN, or Poste de Commande Navigation, the panel used for controlling the inertial navigation system. The PCN panel is fairly typical of early INS controls. It consists of a 7-segment display which shows various parameters, a bank of indicator lights which tell us what the INS is currently doing, a typical alphanumeric keypad and associated function buttons for inputting information, the PCN mode selector knob, which determines the main operation of the system, as well as a parameter selector knob, which selects what to display, a waypoint selector thumbwheel, and a panel light switch. We have already used some of these controls in our previous tutorials. The mode selector is currently set to the arrêt or off position. The current data stored in the INS can be viewed by setting the mode to VI or standby, and can be edited if required. PP on the parameter selector knob stands for present position, and displays the current position of our aircraft according to the INS. If this is incorrect, this must be re-entered and the aircraft realigned according to the procedures shown in the cold start tutorial. Setting the parameter selector knob to POS will display the coordinates of the waypoints that have been programmed in the mission editor. Waypoints are called buts, the French word for target or aim. Each waypoint or but is selected for display using the thumb wheel. Due to an anomaly with the way the Mirage F1's INS system works, the numbers of the waypoints do not correspond correctly. Waypoint 1 in the cockpit typically corresponds with waypoint 0 in the mission editor, the aircraft's initial position. Cockpit waypoint 2 corresponds with mission waypoint 1, cockpit waypoint 3 is mission waypoint 2, and so on. Henceforth, we shall refer to the numbers used in the cockpit as the INS waypoint addresses. The Mirage F1 uses the degrees, minutes and decimal minutes format to 1 decimal place for coordinates, which are here shown on the display. The small triangles on the display separate out the components of the coordinate. Hence, cockpit waypoint 2 selected with the thumbnail, which corresponds to St. Catherine's Monastery, reads 28 degrees 33.7 minutes north and 033 degrees 56.9 minutes east. Indicators for north, east, south and west are above the numbers on the display. Note that the Mirage F1's INS does not have an altitude element to its waypoint positions, only latitude and longitude. Let's set the thumb wheel to display INS waypoint 5. The coordinates for INS waypoint in address 5 should correspond with the Great Pyramids of Giza, but this has been incorrectly inputted by the crew chief. The waypoint information can be edited simply by moving the thumb wheel to the INS waypoint in question and overwriting the information using the keypad. The correct information is shown here. First, press either N for north or S for south to edit the latitude. Enter the desired ordinate in the correct format and then press the Insert button, which will illuminate to remind us. Repeat the process for the longitude, commencing with either E for east or W for west. If you make a mistake, press the clear button and start again. Waypoint position information can be edited like this in the other modes selectable on the PCN mode selector knob. On the mode selector knob, CAL, standing for calibration, and test are not used, as these are used by the crew chief for maintenance. ALCM, ALR, and ALN are the alignment modes discussed in the cold start tutorial. Nav is the main navigation mode, and the system must be set to this before moving the aircraft after we have aligned it. SEC, standing for Secours or Emergency, places the system into an emergency mode, which limits the information provided to the F1 EE's navigation system. It is standard practice to leave the parameter selector knob in PP present position when not utilizing the other modes. So our yellow flashing alert indicator usually means we need to align our aircraft, so we will quickly do this, after which we will set the mode to navigation and get up in the air. With our INS waypoints saved in our system, we need to tell the Mirage F1 that we wish to use them for navigation. First, we need to ensure our INS is set to navigation mode on the PCN, which we should have done before departure. Our primary navigation instrument is the IDN navigation indicator, which operates similar to a typical horizontal situation indicator found in other aircraft. The lubber line, aligned with the 12 o'clock position, indicates our current heading. First, we need to set the IDN to queue off the inertial navigation system, which is done using the IDN mode selector, or the outer collar of this knob here. The mode is indicated by this wedge-shaped needle. NAV refers to INS navigation, and RNAV refers to TACAN radio-based navigation. Each mode has an N or normal setting, and a VA, vector additionnel or offset setting. We will select NAV-N mode, the main mode for INS navigation. In doing so, the larger wide white needle becomes activated and will point to the selected INS waypoint. The number displayed in the window is the distance to that waypoint in nautical miles, with the last digit representing tenths of a mile. An amber striped flag appearing in this window next to the illustration of the wide needle indicates that the needle has suffered a fault. Other features of the IDN will be discussed in the future and in other tutorials. In order to navigate, we need to pass the information from the INS to the IDN navigation indicator by selecting a waypoint. The current selected waypoint is INS waypoint 1, indicated here on the LCD display in the vers or towards window. This was our initial point from which we have just departed. We need to select INS waypoint 2 for St. Catherine's Monastery. To do so, we select the INS waypoint we wish using the thumb wheel and then press the asterisk button to select it. Without pressing the asterisk button, the information will not be passed to the IDN. We can see that this updates in the vers selected waypoint window. The IDN has now reconfigured to show the bearing and distance to the selected waypoint 2. All that remains is to maneuver the aircraft in such a way as to place the wide needle in line with the lubber line or 12 o'clock position. We will now fly this heading for just under 124 nautical miles. Okay, we are coming up on our first nav point, St. Catherine's, which is nestled in a valley between the Sinai Mountains, just under 10 nautical miles. My apologies to the abbot and the monks for disturbing their peace. Waypoints do not automatically advance to the next as in some aircraft, so we must manually select our next waypoint using the thumb wheel and the asterisk button. Sharm el-Sheikh is 47 nautical miles off to our 3 o'clock. As we approach our next destination, let's look at some of the other features of the PCN panel. On the parameter selector, the option CDI is used for INS maintenance and is not utilized in this simulation. STS or status we have used in our INS alignment. We have already seen PP showing our present position and POS showing the position of each stored waypoint as selected by the thumb wheel. VS/RT stands for Vitesse au Sol Route and shows on the display our current ground speed in knots on the left and true heading on the right. Delta L/Delta G represents the difference in distance to the selected waypoint in nautical miles. Here, this is displaying approximately 31 nautical miles, and this will correspond with the distance displayed on the IDN. The light switch can be used to adjust the overall brightness of the PCN's display, from jour or a day setting to nuit or a night setting. And as we can see here, the display and indicator lights can also be tested by setting the switch to test. Okay, we are coming up on Sharm el Sheikh, just ahead of us in about 20 nautical miles. As we advance our navigation systems to and turn onto our next waypoint, we need to consider the threat of INS drift. If you are familiar with this, feel free to skip the next section, but first a short presentation on some important concepts. In this briefing, we will consider the fallibility of inertial navigation systems with the concept of INS drift. The main benefit of an INS is that a waypoint can be placed just about anywhere, and does not rely upon an external source such as a beacon to operate. However, inertial navigation systems are not perfect, as they suffer from a phenomenon known as INS drift. These systems rely on an intricate combination of gyroscopes and accelerometers to provide inputs into a navigation computer. As they are not 100% perfect, errors in the cumulative inputs build up over time, the result of which is that the INS waypoints no longer correspond with their exact true locations, even though we set our initial position and aligned the system correctly. Consider this flight plan here, consisting of 3 waypoints, the last of which is a target. As our aircraft flies the route of the plan, the INS errors begin to accumulate, causing the waypoints to drift from their true locations. If the flight is sufficiently long, it is possible that by the time we reach the target, having followed our navigation instruments, our waypoint is nowhere near where it is supposed to be, making a precision or coordinated strike difficult or even impossible. To combat this INS drift, we can add an INS Fix waypoint in the middle of our flight plan. This is a waypoint that corresponds to an easily recognizable ground feature, such as a distinctive building. Upon approaching this waypoint and observing the ground feature from the air, we can fly over the feature and execute an INS Fix. This has the effect of resetting the position of the waypoint over the feature and realigning the flight plan over our desired locations. We can then continue with our flight plan and hopefully arrive at our target with reduced, limited, or minimal errors. Thank you for listening. Now let's see how this could affect our beloved Mirage F1. Okay, we are approaching the southern entrance to the Suez Canal, and just beyond it, we will find our INS waypoint number 4 at Kibrit Air Base. As we approach Kibrit, the IDN indicates that it is directly in front of us at a distance of 12 nautical miles, However, observing the base from the air, it appears to be a few degrees off to our right. This suggests that our INS may have suffered from a small amount of INS drift. To help remedy this, we will execute an INS fix as we fly over our next waypoint, INS Waypoint 5, which corresponds exactly with the peak of the Pyramid of Khafre. We have set the PCN to Waypoint 5 and selected it as our VERS waypoint. As we have chosen something that is easily recognizable from the air, in this case one of the pyramids at Giza, we should be able to spot it and fly over it exactly, even if our navigation waypoint has drifted. To execute the INS fix, we will press the INS vertical designation button on the PCN, which looks like an upturned uppercase T. The vertical designation button must be pressed at the same time as we fly over our recognizable feature that corresponds with the coordinates of the waypoint. Okay, we are approaching the central pyramid. Let's set the parameter selector knob on the PCN to delta L, delta G, as this will measure our INS drift. So, timing this right, we're going to press the button when we are directly above the peak of the pyramid. And vertical designate. Having made our INS fix, we must decide whether or not to accept it. The delta L delta G measurement says we have experienced 0.1 nautical miles of drift, which is not unreasonable. If the drift was very large, this may indicate to us that we have made some kind of mistake. If we are happy to incorporate the INS fix into our system, we press the illuminated Valid button on the PCN, standing for Validate. This has the effect of readjusting our INS waypoints to more accurate positions, and we can continue on our journey knowing that our navigation system is more accurate. For very long flight plans, it is perfectly reasonable to incorporate a number of INS fixes along the way with recognizable landmarks. Well, as ever, I hope that was useful for you. We'll be looking at many other different navigation features, such as offsets, in our upcoming tutorials, but you now have all the basics needed to fly a simple INS flight plan. If you are wondering, Guy Nautico-Lobomasophilic describes someone who enjoys chewing on women's earlobes. With genuine thanks to my patrons, especially Jan11, Lakota21, Plabs, Blake Armin, Starlover, and introducing our latest supporter, Ben. Thank you for keeping up the support during some difficult times. Feel free to do the usual thing, like, subscribe, comment, and share, but until next time, virtual aviators, keep on rocking and keep on flying. This is Reiver saying last call.